Hello class, in this video I'll be introducing the limit definition of derivative. Let's begin. The derivative of a function f of x at a point x is defined as follows. F prime of x, or the derivative of f, is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h, provided that the derivative exists at the point x. Now this formula looks very similar to the instantaneous rate of change formula that you saw in section 11.3. The difference here is that x is a variable and represents the real numbers in the domain of f of x. What this means is that the derivative can be used to measure the instantaneous rate of change of a function at any point on its domain, provided that the derivative exists at the point. So let's take a look at an example. In example 5, we're going to let f of x equal 7. And before I apply the limit definition of derivative to find f prime of x, I'm going to graph this function in Desmus. So I've gone ahead and graphed the function in Desmus. And you'll notice that the graph is a horizontal line. The slope of a horizontal line is 0, which means the instantaneous rate of change along any point on this line is 0. And I want you to keep that in mind when I find the derivative of f. So we have the derivative of f is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. To evaluate f of x plus h, I'm going to substitute x plus h in for every x in the function. Since there are no x's in the function, f of x plus h is just equal to 7. F of x is also equal to 7. So the derivative is the limit as h approaches 0 of 7 minus 7 divided by h. The 7's zero out, so the derivative is the limit as h approaches 0 of 0 divided by h, which is equal to the limit as h approaches 0 of 0, which is just equal to 0. So the derivative is equal to 0. And why is the derivative equal to 0? Well, going back to the graph, the slope of the horizontal line is 0, which means the instantaneous rate of change of this function along any point is going to be 0. And since the derivative measures instantaneous rates of change, the derivative will also equal 0. So now we're ready to answer question B. What is the instantaneous rate of change of f of x at x is equal to 2? So the question is actually asking us to evaluate f prime of 2. From part A, we know that the derivative of the function f is equal to 0. So this implies that when we evaluate the derivative at x is equal to 2, the result is also 0. So the instantaneous rate of change of f of x at x is equal to 2 is 0. And we are done.